My name is GyamiShrestha. I'm the director of the US Carbon Cycle Science Program Office at the USGCRP. I will address briefly an interagency perspective on coordination needs for forecasting carbon cycle. A disclaimer: the views expressed herein do not necessarily represent those of any federal agency unless specifically stated. The US Carbon Cycle Science Program was established by the Carbon Cycle Interagency Working Group in 1999 under USGCRP auspices. The USGCRP itself was mandated by Congress in the Global Change Research Act of 1990 to assist the nation and the world to understand, assess, predict, and respond to human-induced and natural processes of global change. A few years ago, we sponsored a workshop on carbon cycle predictions led by Dr. Yichi Liu. We recognized in our report that one important step toward carbon management is developing the science that predicts carbon cycle. Over the past 10 years, the North American Carbon Program has helped to significantly advance observation and monitoring systems in carbon cycle research. Observations and monitoring programs such as AmeriFlux and the NEON network are essential to improving understanding of the carbon cycle through diagnostics of the magnitude, spatial patterns, and temporal variability of carbon fluxes and stocks. However, the value of these programs would be greatly increased if their results could be used to constrain future projections of carbon cycle dynamics in response to climate change and human dynamics, including carbon management efforts. The best example of our interagency needs and uses for carbon cycle forecasting can be found in the second state of the carbon cycle report, or SOCR 2, which my program led with over 200 interdisciplinary experts from around the world. Here is a word map of the executive summary alone, which summarizes this almost 900-page sustained assessment of the last decade of carbon cycle science across North America. Clear needs and uses of ecological forecasting for land, water, atmospheric, and societal carbon dioxide and methane flux studies to inform better carbon management and mitigation practices and technologies across scales are demonstrated in each sectoral and ecosystem-based chapter. Multiple key research findings and needs are identified, including in ecological forecasting. The use and value of collaborative interagency carbon forecasting has been demonstrated clearly during current real-time carbon dioxide analysis of COVID-19 impacts, as described by colleagues in last week's article published in Carbon Brief. Emissions from fossil fuel burning, land use, and cement productions, as well as predicted changes in natural carbon sinks and sources as a response to recent and predicted climate conditions, are used to forecast the atmospheric carbon dioxide for the coming year. This piece reflects NOAA, EIA, and UK Met Office coordination to utilize data from multiple agencies and institutions and each other to make these forecasts possible. The article highlights the minimal impact of emissions reductions on the carbon dioxide forecast, illustrating the critical point that carbon dioxide and carbon dioxide concentrations are not the same thing. Emissions are the amount of carbon dioxide being released to the atmosphere by human activity, including fossil fuel burning and deforestation. Concentrations are the amount actually in the atmosphere, which shows the importance of understanding the variables behind any forecast. There is a clear demand for increased quantity and enhanced quality of carbon cycle data and models across scales in order to adequately forecast future concentrations of carbon dioxide and consequent global warming. The EFI RCN workshop organizers asked me these questions. There is not enough time to address them, but I hope that we can continue exploring answers and newer questions in the future together. The USDA's new Agricultural Innovation Agenda has recently been released for public input. A need for ecological forecasts for multiple benchmarks, such as agriculture productivity, forest management, food loss and waste, carbon sequestration and greenhouse gases, water quality, and renewable energy is demonstrated throughout the agenda. There is a need for enhanced communication, collaborations, and coordination among agencies and programs, such as NEON, the US Carbon Cycle Science Program, and others across observations and data collection platforms, and in situ sensors, integration and application of atmospheric, physical, oceanographic, chemical, and ecological models, data management and analysis, computational capacity, test beds, capacity to develop and test new algorithms with a holistic view of infrastructure requirements to be more effective in pursuing and applying resources. Throughout the agencies and user communities of the US Carbon Cycle Science Program, such as GyamiShrestha, there is a need to know how long the forest sink in the US will remain, whether the forecasted trend in sink strength is related to the health of ecosystems. How do we use transitions between ecosystems or within ecosystems to better understand carbon cycle dynamic disturbance maintained ecosystems? Do we know at what level of natural disturbance an ecosystem could lead to the highest carbon balance while keeping biodiversity and other services? For restored ecosystems, there is a need to forecast the change of carbon and greenhouse gas climate warming potential over time. How long will it take to achieve those of a natural system? Finally, we need to have models that link hydrology in an upstream to ocean continuum to understand behaviors of wetland carbon. There is currently a request for information by May 15 on Earth system predictability, research and development. The deadline is coming up, so I would urge everyone to provide input now. For details, you can go to beta.sam.gov. I would like to end with an excerpt from an unpublished manuscript that we worked on under the leadership of Ichilio. To narrow the gap between the theoretically expected and actual model predictive abilities, we need to develop our research capacity, example, infrastructure and human resources, to fully use big data from multiple sources, foster interactive operations of modeling with observations or experiments, and to design observatories or experimental systems to understand, prepare for, and counteract potential previously unanticipated changes in the global carbon cycle. Efficient development, provision, or availability and presentation of robust information on the current trajectories of the global carbon cycle could help to improve the effectiveness of climate change mitigation via carbon management. Thanks.